Good morning. I'm Donata Magrini. I'm a researcher from the Institute of Heritage Science of the National Research Council in Florence, and I'm a member of the Italian Association of Archaeometry, AIA, which is an association of scholars and researchers working in the field of scientific application to cultural heritage. Today, I'm glad to present you some result about the project Paestum Inside the Lights of Science, which is a project promoted by AIA in collaboration with the Archaeological Park of Paestum, aimed at studying decorated tombs preserved at the archaeological site of Paestum by means of a multi-analytical and interdisciplinary approach in order to define the executive techniques as well as the chronological evolution of technological skills of artisans. The whole research activity has been focused on the characterization of pigments and binders, on the petrographic study of mortars, and on the quantitative characterization of mineralogical phases. For this reason, a multidisciplinary team was created in order to characterize materials, and here are listed all the researchers involved in this archaeometric study and their institutions. The listed scientific methodologies have been applied in the research project. The archaeometric study of painted slabs has been preliminary based on a non-invasive approach performed in situ by portable equipment. More than 400 single spot techniques, measurements have been collected by using different analytical technique, and the spots were selected according to the results of multiband imaging techniques. In the present speech, just the preliminary data provided from the in-situ activities of the first step of the research project, which was mainly related to the characterization of pigments, are here reported. The investigated tombs displayed at the museum or stored in the deposits come from Hellenistic and Lucan necropolis. The tombs were usually box-shaped with the 4 slabs of local travertine forming the walls, closed by a double sloping roof or by a single horizontal slab. The funerary painting can be considered as an indicator of social distinction, and probably the choice of images is representative of the ideals of the hegemonic classes. Besides that, also the choice of the raw materials could represent an important indicator for solving archaeological questions about the external or local artisanal tradition, as recently suggested by new hypotheses following the discovery of the tomb of the Palmets and its similarity to the tomb of the diver. The investigation was performed on the pictorial surface of the listed frescoes tombs, starting from the well-known tomb of the diver, from the Tempa del Prete necropolis, and 13 more tombs here report and here shown in this slide. Integrated and multi-analytical approach provided significant results for the identification and the clustering of pigments palettes, typical of different periods. In the next slide, for each pigment, the results obtained from the whole set of analytical techniques used for in-situ measurements are reported. Here, in this slide, the light blue layers where I investigated with in the painted slab of the tomb of the diver and in Andriolo tomb number 6, belonging to different periods. The first one, the tomb of the diver at the end of 6th century, while the Andriolo tomb number 6 is from belonging to the second quarter of the 4th century before Christ. X-ray fluorescence detected the presence of copper, along with calcium and lower amounts of aluminum, silicon, iron, and strontium. And the presence of copper suggested the use of Egyptian blue as the main components of the blue pictorial layers, and this data is confirmed by reflectance spectroscopy and FTIR, infrared spectroscopy. Egyptian blue is a famous synthetic pigment which is constituted by cuproivalite blue crystal and obtained by the mixture of silica sand, lime, compounds of copper and fluxing. Visible induced luminescence images confirm the results obtained by single spot techniques and halo to localize Egyptian blue. Here, a detail from the tomb of the diver. On the green pictorial layers, two main typologies of mixture of pigments have been observed, mainly discriminated on the basis of their composition. The first type of green pigment was characterized by the presence of iron along with calcium. Infrared spectroscopy also evidenced the presence of silicates. So for these areas, green earth was used. Green earth is a natural green pigment characterized by the presence of hydrated silicates rich in iron, as glauconite or celadonite. The second typologies of pigments of green pigments was observed in correspondence of decoration depicting the leaves. Here an example from the tomb 21, and they are characterized by the presence of copper along with calcium and iron. Compositional feature as well, the high absorption of visible light and luminescence in the near infrared region suggests the presence of Egyptian blue pigments, likely mixed with another color for obtaining the green shades. In the slide, the detail of the upper frame with the leaves from the tomb 21 acquired in the middle with a digital microscope. They show the presence of the heterogeneous blue pigments grains and the visible induced luminescence image. Here, the graph with the two clusters, distinguishable on the basis of the Egyptian blue content in mixture with iron-based pigments. For the dark and light shades, red layers have different compositional characteristics that allow to distinguish three different groups. The first group is characterized by the presence of iron and low counts of aluminum, silicon, potassium, manganese, and sulfur, as highlighted by X-ray fluorescence. Reflectance spectroscopy positively identify iron-based pigments in almost all the tombs where Raman spectra acquired show the bands related to hematite pigment. Moreover, FTIR in the tomb 12, 21, and 110 identified the silicate signal. This could be linked to the use of a red ochre containing iron hydroxide and oxide and silicates. The second compositional group was constituted by red hues showing, along with iron and calcium, the presence of arsenic that suggests the use of different red pigments. Although reflectance spectroscopy and infrared and Raman did not show any significant spectral evidence, the compositional characteristics could be indicative of a mixture of pigments, likely constituted by iron-based pigments and an arsenic-based pigment used on the red layers, both in lighter and darker shades. Finally, the third group, in addition to iron and arsenic, in the tomb of the diver, in the tomb of the palmets, and in the tomb 314, the presence of lead has been detected in the red hues. Here, the B plot of the intensity values for X-ray fluorescence lines of iron, arsenic, and lead, identified for the red, pink, and orange layers on the painted tombs. For the yellow paints, different compositions were found, in particular yellow decoration in the tomb of the diver and the tomb 6 contain arsenic along with calcium. Although the use of arsenic-based pigment could be suggested, the correct identification of this yellow pigment requires further analytical investigation. By contrast, the yellow layers analyzed in the other tomb are instead made of iron-based pigments. In particular, with the goethite is identified by Raman. The calcite is the main mineral in the white layers on the wall set of analyzed tombstone, while Raman allowed the identification of carbon black pigments on the black pictorial layer of the tomb. Concluding, the project articulated in a preliminary in situ investigation by means of non-destructive analytical techniques shed light on the decorative techniques and pigments adopted from the Hellenistic to Lucan period. Valuable information on the palette used for decorating the slabs was here presented. Single spot technique confirmed that the artist's palette is quite limited and coherent with the contemporary funerary art in the Mediterranean basin. Red and yellow ochre prevail on other pigments, whereas the use of Egyptian blue and of a red ochre enriched in manganese is interesting, and deeper studies on these materials could be useful to better clarify the commercial background of Paestum during the 4th century before Christ. And most of the colors used were obtained by mixing pigments, whereas calcite was added to obtain lighter shades. The choice between one mixture or another could be linked to both the availability of raw materials, but also to the stylistic preference of each workshop. In order to better understand any similarities between the different necropolis of Paestum and any changes over the time, further analytical measurements on microsampling are ongoing for investigating the manufacturing techniques used for the pictorial layers and to underline and the underlining plaster. The feature of painted tomb, as well as those of other public buildings, such as temples, will also permit to deepen the knowledge on the production technology adopted from the end of the 6th and the first half of the 4th century before Christ in Paestum, and also to evaluate the possible changes occurred during a time span of about 2 centuries. I would like to thank the whole staff of the IR team and the staff of the Archaeological Museum of Paestum and you for your kind attention. Thank you.